Good morning, everyone, and welcome to today's webinar, Manage Your CAD to eBOM Process. My name is Carolina Haig, and I will be your co-host and technical support. And presenting today is Martin Toreskog.
This is the first session out of 3 where I will cover the CAD to eBOM process. I will do quite a lot of demos today, but some short PowerPoint presentations as well. And then we will end with some questions. So first, some definitions. CAD documents, we will talk about that, including 3D parts, 3D assemblies, 2D drawings. And then the part object or item. In some cases, I will say part, but I then refer to 3D CAD parts. But yeah, it could happen that I refer to part as both CAD documents and part, but I will try to be as clear about that as possible. So the part or the item represents the part number, in this case 15, 25, 22. And the part object acts as a placeholder for all documentation related to that part number, which could be CAD, it could be a 2D drawing, it could be a PDF, it could be any type of documentation. Then we have the eBOM, which is the engineering bill of material. So the BOM according to engineering. But companies often have a need to sort of restructure that BOM to fit manufacturing needs. So that's the mBOM, manufacturing bill of materials, and then sBOM for service bill of materials. But those two topics I will cover in later sessions here. So CAD documents are managed in Windchill. Parts, assemblies, and drawings, they are version controlled with revisions and maturity, or the state, as we call it. Windchill is a CAD neutral PLM system. I will demonstrate in Creo today, but it will look basically the same for the majority of CAD systems like Inventor, SolidWorks, CATIA, NX, and so on. The parts or items are automatically created when you check in a CAD document. So if you have a CAD part here and check that into Windchill, Windchill will then create the item and automatically associate the two. And the same thing for CAD assemblies, and then reflecting the same bill of material as described in the CAD. But then you can build upon this engineering bill of material, adding other parts that do not have a CAD representation, like software and things of that nature. Any changes made to the CAD will be reflected in the BOM, so they're fully associative. And then, as I said, you can add additional documentation to fully describe the part. Once you have the engineering bill of material, that can be leveraged to create a manufacturing bill of material and a service bill of material. And those are also associative to the eBOM. So if you have your CAD structure, but you have some CAD parts or some CAD assemblies that should not be represented as a part in the BOM. For instance, it could be reference geometry and things like that. You can, based on a CAD parameter, exclude the creation of a part or an item. So this example, I've created a CAD parameter called reference model. If I set that to yes, then the item for that CAD part will not be generated. So then you can describe your CAD structure the way you want, but the BOM will then reflect what it should reflect. So I will go into the demo section here. So I will first display or show you an already created engineering bill of material with the associated documentation. And then I will check in a CAD assembly, a new CAD assembly, and show you how you can create the parts and build the BOM. I will show you the example of excluding the part creation for some of the parts. And then I will update an existing engineering bill of material. So, Carolina, let me know if you can see my Windchill screen now.
Absolutely, it's working just
perfect.
Fine.
So currently I've navigated to my go-kart BOM here. So it's the Lego model, and we can see in the structure tab here, we have the bill of material. And then you can see that some of the parts have a little triangle left of it, and then that means basically that it has children. So selecting a part in the BOM will then select the geometry representing those parts. If you select a part in the visualization, then it will be selected in the BOM as well. You can see the metadata of the parts in this table view here. So we have the number, the name, if there's a change going on any of the parts, the version, the state, and so on. And any metadata of the parts can be displayed in these table views here. So any user could define their own table views displaying specific information about the parts. But you also have the attributes tab here. So selecting a part here will then display the metadata of that part in this pane here. If you want to see the attributes and the visualization at the same time, you can simply display or change the display mode to, for instance, a 3-pane display. And then I have the visualization, have the attributes here. So if I want to see them at the same time, I can simply drag and drop this tab to this section here. And then I can then select, let's say, this part. It will be selected in the BOM, and then I have the attributes related to that part here. So I will change it back to the 2-pane display. So this is a web browser. So the 3D geometry is possible to display for any user that has a web browser and a login to Windchill. So you don't need to have a CAD system or anything. But the 3D representations are, of course, defined or generated based on the CAD models. So if I select a few parts and then click Show here, we can see that related to all of these parts are some CAD documents. In this case, we have a 2D drawing, the 3D assembly, and then we have some other types of documentation, software, for instance. And then you can add additional documentation to each of the parts. So with that said, this is sort of an introduction to Windchill in general, but I will move on to Creo. So here I've opened a new seat. So remember, in this case, it's a different seat with a different number, of course. But what I will do is check in this newly created assembly. I will not create any CAD models here, but I've basically opened this from my hard drive. And we can see in the model tree here that we have an asterisk left of the CAD documents. And that basically describes that this has never been checked into Windchill before. If I expand my model tree a little bit here, we can see that I have a column here that says ref model, and I've set this supporting geometry here. This is not part of the BOM, so I basically just added that as a reference to where I should place the seat. And I've defined the value for that to yes, and that means that when I check this into Windchill, Windchill will create items for each of these parts, but it will exclude the creation of an item for this particular CAD document. I also added another parameter here called specification. So any CAD parameters or CAD attributes can be pushed to the parts, the items, and you will see that shortly. So what I will do is simply save this to Windchill, and then I will right-click my my top-level assembly, and here you can see that I have Windchill actions. So this will be the same for other CAD systems. What I will do now is I will select custom here. Auto check-in will automatically just check in the CAD documents, generate the parts, generate the BOM. Custom will let me do some additional preferences when I check them in. For instance, decide where, in what folder these should be stored in. So I will select custom, and then I'll click OK. What Windchill does now, it's using the CAD system to generate the 3D representations of the parts. And of course, you can let Windshield do that, but in this case, I let the CAD system do it. Here's the list of CAD documents that will be checked in, and we can see the location here. So if I want to, I can change that for all of these and set specific locations for each and every row here if I want to. I'm not going to care about that right now, so I will simply click Finish. And what happens now is that the asterisk disappeared, so that means that these parts are now checked into Windshield. If I would navigate to the Windshield page of this CAD document, I will close the model tree now. We can see that now this is checked into Windshield. If I go to the Related Objects tab and scroll down just a little bit to parts here, we can see that it has generated a part with the same number as the CAD document, excluding the file extension here. So if I navigate to this part, and as you can see, I'm navigating Windshield inside Creo here, but if I would do it in the browser, it would look exactly the same. It's just a built-in browser into Creo. So I will click the Structure tab and maybe expand this a little bit. Waiting for my internet connection. Let's do this instead. I will go to the browser and view this instead. So here you can see that the BOM that has been generated is based on the CAD, and the reference geometry that I had, as you can see, that is not represented here. The number of that, if I go to Creo here again, if my computer will allow me. A lot of issues today here. So yeah, it's doing something there. But you have to trust me on that. And of course, you cannot see the frame that you saw in the CAD tool. Also, the attribute that I added to this top-level assembly, the Lego 8256, has been populated to my part as well. And this is also searchable. So any metadata of the parts or the CAD can be used as a search criteria when navigating in Windshield. So let's see. What I will do next is go to the Lego level here, and I will actually replace the seat with a newly created seat that I just created. So what I'm going to do in Creo is right-click this and say replace. And then this is an unrelated component. They have nothing to do with each other, but I will then simply browse for my newly created seat. And this is a Creo-specific feature where I can map the references, the assembly references between the old model, this one, and the new model, this one. So it includes all the references needed for assembling this particular component. And this hole here should be this hole here. It then checks out my assembly because I'm modifying it. So when checking this into Windshield, it will create a new version of this Lego car. And then you can see that the assembly has been replaced with the newly created CAD assembly. And we can also see that the number of this is the assembly that I had, 9991111. So what I'm going to do is check in my top level assembly. And then I will go to to Windchill and just take a look at this. So this was the old version of the CAD assembly. If I refresh this page now, you can see A.1, it said here. Now it's A.2, so I've modified it. And then if we take a look in the BOM, we should have my 999111 part here. And if I click the visualization tab, it will then be reflected in the visualization as well. So here you can see that the new seat is then reflected in the same way as it was in the CAD. So moving on, let's say that you have created some CAD documents and built some engineering bill of materials, but you don't have all the CAD documents needed to fully define the engineering bill of material. So I've created this 1, 2, 3, 4, 5, 6 part separately, and I've defined all the attributes and so on for that. If I then later create a CAD document and name it the same way, what Windchill will do when I check this into Windchill is that it will automatically associate the CAD document to the part and then include that in the BOM as well. So you can basically build your engineering bill of material outside of the CAD. Once you have the CAD fully defined and check that into Windchill, the CAD structure will then drive the engineering bill of material. And another example where you have your CAD structure, you built your engineering bill of material, but you want to add additional parts to it, which could be software or regular parts, but they are not represented in the CAD. That part of the structure that is CAD driven will of course be associative. So any changes to this will be reflected here, but it will not remove the additional parts that you have added. The next example is perhaps performance based. So let's say you have a really large assembly that contains large sub-assemblies like this. When you check that into Windchill, Windchill will then of course generate the engineering bill of material accordingly. But if you want to replace this assembly with a simplified version of it, so in Creo we would typically create what we call a shrink wrap, which basically takes all of the geometry included in the CAD assembly and include that in the part. So this is a lightweight version of this CAD structure here. Then you can simply replace the CAD assembly with a simplified version of that CAD assembly. So then the BOM would look like this, or the CAD structure would look like this. If you associate this simplified version to the same part, so now we have the CAD assembly and the CAD part associated to the same item. If you check this into Windchill, then it will still keep the fully defined BOM in the engineering bill of material. And if you would create a new assembly and include these simplified versions of the CAD, then it will reflect the BOM, the fully defined BOM, basically. So this allows you to open the assembly faster. And of course, if you're working on this part of the CAD structure, you can simply replace that with a fully defined CAD assembly, keep working, checking that into Windchill, and the BOM will still be intact. The last example that I will show here is an example from Väderstad, where they create the CAD structure up to a certain level. In this case, for instance, a frame or a wheel suspension or a marker or similar. And they drive the BOM up to that level, but then they create the fully defined engineering bill of material for the product by adding these modular E-BOMs to that. So there's no CAD associated to the top level here, but they get the fully defined engineering bill of material. And in this case, it's actually configurable BOM. So they have different frames for different configurations, and then they can generate all the different possible variants based on this. But first, I will cover the example that I started with. So I have created a part called 872214. If I search for that, I only find an item, a part. I don't have any CAD associated to this. But if I go to Creo now and create a new part and call it the same thing, I will call it the same thing as well, 872214. And then I will just create some simple geometry, just so we have something to look at. Let's do it this way, and then perhaps. So what I'm going to do is simply check this into Windchill, and what will happen is that Windchill will then find that particular part, the item, and automatically associate itself to that part. So if I go back to my search result here and go to the item, and then click the show button here to show the associated documentation, you can see that now it has found that part, and then in the visualization you have the 3D representation that I just created. If I then add this part to an assembly, and of course then this part will be included in the BOM. So the next example is if I go back to my Lego car here, this one. So at this point, the BOM is fully driven from CAD. But what I want to do is add an additional part to this BOM. So I can insert a new part. That will check out my top level item. And here you can see that it's possible to define different types of parts. So in this case, I want a software part. The number for that is automatically generated. Let's see if we call it software build. We'll click finish. And then that item is then added to my bill of material. But if I would change any of the CAD assemblies here, then those will be reflected, but this will still be included in my bill of material. And then, of course, you could add the actual software as a document related to this part if you want to. And you can build upon that, so you can build your own bill of materials the way you want, in a structure that you want. That will be intact once the CAD is updated. So the next example is that I will, and now you have to imagine that this is a really big, a large assembly. It's not, obviously, but what I will do is create a simplified version of this seat here. And I've done that in advance. So I will actually just open a predefined part here. So this, as you can see, it doesn't have any holes and so on. So this is a shrink wrap that I've created based on my seat. So let's imagine that the seat is a really big assembly. So I will not do a regular check-in in this case, because then it would create an item called 999111_SW. So what I will do is save this and then go to my so-called workspace, which is my local storage area when I work with CAD. So here I can see the status of the parts, the CAD documents, the CAD assemblies, and so on. We can see that this part, a CAD part that I just saved, is a new part. All the other are checked in. So what I want to do is actually select this one and then select the item that I want to associate this to. And then I will select Edit Associations. It will then display the CAD assembly that's already associated to this part, but it will add this association to my CAD part. I will click OK. And then I will check in this, this newly created part. So what will happen now is that if I go to this part, the seat here, let's see, this one, I will actually just refresh my page. And if I show the documents associated to this item here, let's see if it allows me to do that. Let's select documents here instead then. Here you can see I've selected this part. We can see that the CAD assembly and the CAD part are associated to that. So what I'm going to do next is go to my assembly and simply replace this CAD assembly with my simplified version of it. So I will do the same way as I did when I replaced the seat. I will select my simplified version. And then I will just map the references between the assembly and my simplified part. So I will just, then I know which references it is. It will check out my CAD assembly and then replace that assembly with the simplified part. So here you can see it's only a CAD part. It's not an assembly anymore. But if I check this assembly in to Windchill and go back to my bill of material, we can see that I haven't refreshed it now, but as you can see before, I had the fully defined bill of material. If I refresh it now to display the latest version, we can then see that the engineering bill of material is still intact. So regardless if I use the simplified CAD part or the fully defined assembly, I still get the correct bill of material. That could be quite a useful feature. So the last example is from Väderstad, where we have the CAD that is built up to this level, the frame, the wheel suspension, the marker, the hydraulics, and so on. But then they built the top level outside of CAD. So, and we can see here that they actually use options and variants to define the criteria for which frame, which wheel suspension, which accessory and so on should be included in the bill of material. So this, for instance, should be included if the number of row units, which are these yellow and red and black thingies, should be included if the number of row units is 4 or 6. This should be included if it's 12 or 18, and so on. So you don't have to use Creo or the CAD system to fully define the top level bill of material. So, Carolina, with that said, I think we are, if there are any questions, we can take that.
Yes. So we will begin with the first question that came in now. What if my CAD files don't have the same number as the part/item? Can they still be associated to the parts?
Yes. So in the example that I showed here, I named the CAD file to the part number. But in some cases, the part number and the CAD number is not the same. So if there is a rule, let's say that you add a suffix or a prefix to the part number. That can be, then Windchill can be configured to support that. But if they're completely different, you would need to create the part separately, the CAD separately, and then in the same way as I associated the simplified version, you would then go and manually associate them to one another. But once you've done that, you can build your CAD structure the way you want, and then it will include the corresponding part, the item. Yes, it's a little bit more manual work, but it's for sure supported.
And we have the next question. Can you upload the eBOM with Excel file to Windchill?
Yes. So Windchill has a, maybe I can actually share my screen here. If that works. Again, let's see. Let's see if you can you see it?
Yes, it's working.
Yeah. I actually did that last week to for a customer. So what you can do is you can click the actions menu here, and then you have a where is it? Export. Where is it? I can't find it now, but it's possible to export the. Oh, perhaps because it's checked out. Let's do this. Let's do it now. Export importable spreadsheet. So that will export the parts and the BOM, and that format can then be imported. So what I did for one customer was just export a part. So I got the Excel template, and then I just included the parts that I want to update or the BOMs that I want to build. And then if you go to the details page of the product container here, there's an import from spreadsheet. And then you browse for that Excel sheet, and then it builds the BOM or updates the part and so on. Yep.
Excellent. So the next question is, what will the BOM look like if you have revised a part/item in the BOM? Will it display the latest revision or the previous revision?
Yes. Now in this demo here, I didn't show any revisions, and of course, if the parts are released, I will not have the permission to check it out and check it in the way I did. Then I would need to revise it instead. And what happens is that Windchill will always, by default, display the latest version. So here we can see that the version of this is C.1, revision C. And if I create a new revision, then it will show D and so on. But it's possible to display the BOM according to filters. So here I have defined I've saved a filter called latest released. Then it will look at, does any of the parts have a released version? And then you can see it's now A.3 here, which is the released version. And then, of course, the BOM will be reflected on that. And then the visualization, of course, will also be reflecting that. And there are compare tools where you can compare the latest version to the latest released version and so on. Hopefully that answers the question.
I think so. We have another one here. Can you associate an extra assembly instead of a simplified part?
An extra assembly?
Yes. Can you associate an extra assembly instead of a simplified part?
Yes. So I assume that they are referring to if the simplified version of the assembly is not a part, but it's an assembly. And yes, then what you basically do when you associate more CAD documents to the same item is that you say that this assembly is driving the structure, and this is just as a reference. So yeah, it doesn't need to be a part, CAD part, it can be a CAD assembly, if that was the question.
I think so.
Yeah.
And we have time for one last question.
Yeah.
Here we have, how are the parts positioned in the Väderstad example?
How they are positioned. Yes. So what Väderstad does is that, as I said, they create the CAD structure up to this level, and in each of these parts, each of these BOMs, they the reason why I get this is that I disconnected my VPN, so I actually don't have access to the page right now. But what they do is that they include a skeleton in the in each of the CAD assemblies, and the skeleton has the global coordinates, so to speak. And so when they model it, if they model this part here, they actually assemble that according to the global coordinate system. So that's how it's done in their case. But I think Anders, a colleague of ours, had another webinar maybe a month ago or something like that, with the dynamic positioning. So it is possible to basically achieve what Väderstad does here without using skeletons, where you can sort of have a matrix where you define the interfaces and so on.
Okay, fantastic. Thank you very much to Martin for this presentation.
Thank you.
Thank you. And thank you everybody who participated. Make sure to participate in the next week's webinar as well. Manage eBOM to mBOM to work instructions as well. So hopefully we'll see you there.
Yep. And then I will use the same example that we did here. Good. Have a nice weekend, everyone.
Have a nice weekend. Thank you.
Bye-bye.
Bye.